Hey, my name is Renell. This is Noah. And that's Jared. And we'll be presenting hydrophobic and hydrophilic surfaces. So hydrophobic surfaces hate water. They want to repel it, while hydrophilic surfaces is the opposite of that. They love water and want to be attracted to it. An example of a hydrophobic surface in nature would be the lotus leaf. On top of the leaf, it's hydrophobic because it wants to, the water removes the dirt, which obstructs the leaf from sunlight. This topic is important because we can use this information to develop material that is waterproof, such as a raincoat. And Noah will explain the drawing on top.
Hello. So, first of all, this first picture here would represent hydrophobicity, showing how this woman here, wanting a man who's muscular and has a lot of money, is repelled from this man who has neither. And this here is hydrophilicity. This man here has one of the things that she requires, and so she stays with him, but she's not exactly satisfied. Here we have super hydrophobicity, which is pretty much just the extreme version of this. She has one of the things she needs, but she's repelled. And here, super hydrophilicity, which is her being extremely attracted to this man because she holds all of her requirements. So what we believe here to be is the muscles represents in a surface to be nanoroughness, which it's nanoscale roughness. It's pretty self-explanatory. It's the roughness of a surface at the nanoscale level. And the money here, we believe, is representative of the chemical functionality of the surface, which is basically what the surface secretes. And so these two things equal hydrophobicity, but the one thing we noticed about this picture is that it's sort of flipped on its head, which Jared will explain.
Yes, as my friend Noah explained, the last picture with the man with muscles and money is actually kind of inverted, because considering hydrophilicity involves no chemical functionality and no nano roughness on most occasions. Nano roughness and chemical functionality would actually facilitate super hydrophobicity, which is actually what the picture on the bottom left would represent. So that's one thing about the image that was a little confusing or could mistrack someone. But other than that, some other things that the image doesn't quite explain is the angle of contact for what would be the water, because contact angle is important because it shows how exactly hydrophobic or hydrophilic a surface is. And to be more specific, super hydrophobicity or super hydrophilicity can be determined by if the contact angle is either less than 15 degrees for super hydrophilicity or more than 150 degrees for super hydrophobicity. And one other thing about the image that could have been refined a bit more is how this technology, hydrophobicity and philicity, could be applied to in real life. For example, there are lots of things nowadays that use hydrophobicity and philicity, both in the natural world and the world that we humans live in. For example, we have a lily plant, which uses super hydrophobicity to clean itself whenever water lands on it, because the water doesn't stick. So it just rolls off the leaf and while cleaning the plant. And yes, that's basically it for hydrophobicity and hydrophilicity. Thank you.
Do you have a question?
I actually just want to start with 2 comments, and then we can go on to questions. So the first is a request to everybody, just in terms of the language that you use, and that is to say every single cartoon that one draws, by definition, captures only some aspects of the concept. And we expect that, and that's part of the whole process. And so it is important to discuss what aspects of the cartoon are not, of the science, are not captured in the cartoon. But they are not things that are left out or failings of the cartoon. They are limitations of the analogy. And so please really think about the language that you use, because it's part of the process that a cartoon will always have limits. And the drawer knew that when they were doing them, and they just, some concepts can't be incorporated into every cartoon. So please think about language when you're doing that. The other thing I just wanted to comment on, and then let you guys maybe say a little bit more, is that for the interaction of water with any surface, there is always a chemical interaction. It is not that sometimes there is and sometimes there isn't. There is always a chemical interaction, and sometimes it's a favorable chemical interaction, and sometimes it's an unfavorable chemical interaction. But all 2 chemicals always have an interaction. So maybe you could say a little bit more about the picture in light of thinking about it with that concept. I think the cartoon can be well explained within that picture. Go for it.
I don't.
So yeah, speaking of chemical functionality, I do admit that, yes, like you said, every surface does have some degree of chemical functionality.
Maybe I ask a different way. Is money a favorable or an unfavorable chemical functionality?
Money in this case would be a favorable chemical functionality if you were looking at it from the point you wanted more hydrophilicity. But yeah, like you said, in real life, chemical functionality would more normally, like you see, like on human skin, oil, it would most benefit hydrophobicity on in that case.
But that's an unfavorable chemical functionality.
Well, yes.
So I think you're exactly right. In this picture, money maps onto a favorable chemical functionality. And so then I think you can explain all 4 pictures in terms of the presence or absence of a favorable chemical functionality and nano-roughness.
Yes, and that's one thing I think we point out, or we would like to point out, that in this case, hydrophobicity and hydrophilicity, the things that would make something hydrophobic or hydrophilic are kind of inverted, because as you see, the super hydrophilic image, the one with both favorable traits, is actually implying nano-roughness and chemical functionality being the...
And favorable chemical functionality.
Correct.
Which is what gives super hydrophilic surfaces.
Oh, correct, yes. No, would you like to add anything?
Other people have to ask questions. I've said enough.
All right, any questions? Yes, actually, we can.
So we had 4 pieces of copper, which would be the surface, and then there was 4 types. One was added to a chemical called decanthiol. Which,
so in general, you guys, for all of you, just like forget the chemical names and just like say what it does.
Okay. Which and we also use
think they just want a very simple description of what is the sample that you made? What did it look like? Because this is the big concept, but nobody right now knows anything about what did the sample look like. Started with copper. What'd you put on it? What were the base ideas of your 4 samples?
So one was with DC was super hydrophobic, where like we had drops of water on each top of the pieces of copper. So one was completely was flat, kind of, and that would be the super hydrophilic, and then another drop of water on another piece of copper was hydrophilic. It wasn't completely like flat, and then another piece of copper was hydrophobic. It was we measured the angles of the drops with a protractors to determine if it's hydrophobic or hydrophilic. So the normal piece of copper had was a contact angle of greater than 90 degrees, so it was hydrophobic. And then the last piece of copper had a contact angle of greater than 150 degrees, which is what make it super hydrophobic.
One of the other of you just tell them a little more about what the sample was? Just like the super short version.
Okay, so in essence, the sample was basically just a piece of copper that was coated in this kind of silverish metallic material that created a degree of nano roughness, which, as we discussed, made it gave it a favorable trait of
rough silver. That's all.
Yeah.
Then
in essence, rough silver.
Treated it with what?
And then we treated it with 2 different chemicals. One was DCM, like you said, and the other was
What was their property?
And in essence, their properties were to either enhance hydrophobicity or hydrophilicity. And that combined with the nano roughness would either make it super hydrophobic or super hydrophilic.